Lesson 1.5, Solving Multi-Step Equations. By the end of this lesson, you will be able to solve different multi-step equations. And this will lead into solving different multi-step inequalities, which will be your next lesson. It's important to know the steps for solving equations so that you can do this effectively. The first step is to distribute if necessary. And let me just remind you what that might look like. So for example, if you have something like this, you have multiplication with an expression inside parentheses. This is where you would distribute. So remember that you would take 2 times x, and then you would take 2 times 2, and you would get 2x plus 4. And that's an example of how you would distribute. So you may have multiple terms like this within your equation, or maybe just one, but that's an example of how you distribute. Number 2, combine like terms if applicable. So that is on the same side of the equation. Perhaps, for example, you have 3a minus a plus 2a. Those are all like terms. Those are all a's. You have 3a's minus 1a, which gives you 2a, plus another 2a, which would give you 4a. So those are all like terms. Number 3, move all variables to one side of the equation. And it says add the opposite, and that's how you do that. So for example, in this situation, if you had 4x over here plus 1, and it equaled 3x over here, we'll say plus 10, we need to move the x's to the same side of the equation. And it doesn't matter if we move the 3x over here to be with the 4x, or if we move the 4x to the right side to be with the 3x. Do whatever seems easiest. So it says do the opposite, add the opposite. Well, this is a positive 3x, so we're going to do the opposite. We're going to subtract 3x from both sides. Okay, and that's how you combine them. So if you'll notice that what ends up happening is 3x minus 3x just gives you 0. So in other words, those cancel out. And on the left side of the equation now, you are left with 4x minus 3x is just 1x, or x, plus 1. And then on the right side, we just have 10 left. Okay? And that is how you move all the variables to one side of the equation. Number 4 says move the constants to the other side. Okay, so in this prior example, I moved my 3x over. Well, now I want to move my constants to the opposite side. Well, right here I've got plus 1. It says do the opposite. So the opposite of plus 1 is to subtract 1. So let's start here. So we've got x plus 1 equals 10. So I will subtract 1. I'm going to move this to the other side of the equation. And then I will add down. So all I have left on this side is x, because plus 1 minus 1 zeroes out, and you get 0 for that. And then on the other side, 10 minus 1 is 9. Okay. Number 5, either divide by the coefficient or multiply by the reciprocal. So let's come up with a new example. So say we have 2x equals 6. We'll do an easy one. Well, 2 is the coefficient, so if you're dividing by the coefficient, you would divide both sides by 2, and you would be left with x equals 3. Okay, and this is because 2 divided by 2 turns into 1, or 1x, and that gives you 3. The final step is simplify or reduce if necessary. Well, I kind of did that in the previous step. 6 over 2, if I reduce that, I get 3. If I had something like 2 over 4, I'd reduce that to become 1/2. Okay, so those are your 6 steps to think about when you are solving equations. Now what we're going to do is practice solving a few, and then you're going to try that on your own in the next practice session. All right, example 1. We have 3x minus 5 equals 9. Okay, so all we have to do in this example is to put our constants on the same side. Well, we want to move the constant negative 5 to the other side. So we're going to add the opposite, which means that we would, instead of subtracting 5, we would add 5. Okay, so let's add 5 to both sides. And one thing that will help you would be to keep this equal sign, think of it as a separation device. Okay, so you've got stuff on the left and you've got stuff on the right. Okay, so think of it as a wall. You're moving things from one side to the other. All right, if we do this, draw a line here and here, 3x is left here. We have nothing here because minus 5 plus 5 goes away. We have our equal sign still, and 9 plus 5 is 14. Okay, and then the next step said to divide, and if we go back, we'll go back really quick. Either divide by the coefficient or multiply by the reciprocal. Okay, well in this case we actually have a coefficient of 3, so we will divide both sides by 3, like this. And we can then write our final answer because these 3's turn into 1x or just x. We still have our equals, and then we have 14 over 3. We can't reduce this, but we could change it into an improper fraction if we wanted to, or just leave it like it is. All right, let's try another example. Let's try example number 2. Okay, so in this example, we're going to do the same thing. We're going to move the constants to the other side. So I'm going to take positive 2 and I'm going to subtract 2 from both sides. And then I'm going to write what I have left. So I have x over 4 equals 5. So how do I get rid of this 4? Well, right now I am dividing by 4. So if I'm going to do the opposite, to get rid of it, I would multiply this side by 4, which is essentially the same thing as 4 over 1. So I'm going to multiply this side by 4 over 1. Okay, and then see what I have left. Well, the 4x over 4 just becomes x, right? Your 4's cancel. So x is equal to 5 times 4 is 20. And you can put it over 1 or just leave it as x equals 20. All right, on to the next example. So this is a little more complex. We have variables on both sides. And like we said before, we want to put the variables on the same side. So we need to do the opposite. Add 5x to both sides. Okay, and I always do that first. Put my variables on the same side. Draw my lines. And then add down, write what I have. So I have negative 7. 11 plus 5 is going to give me 16x. And then on the right side, I'm just left with 9. Negative 5 plus 5 cancels. Okay. Next step is to move the constants to the same side. So again, do the opposite. I have a negative 7. Be careful about those negatives. So I'm going to add 7 to both sides. Draw my line again. This is a multi-step problem, so I've got multiple steps I have to do to solve this. My 7's are gone, and I'm left with 16x equals 9 plus 7 is 16. One final step. What I need to do now is get rid of this 16. In order to do that, I will need to do the opposite. So I will divide by 16. 16 divided by 16 leaves 1x, or just x. And 16 divided by 16, as we said, is just 1. Okay, final example on this page. Now we have a situation where you can see that, oh look, we have a distribution going on here. We need to take care of that, the distributive property. So I'm going to do 5 times x, and then do 5 times negative 1. Be careful, that's a negative 1, so that leaves negative 5 equals 7. Now I will move my constants together to the other side, away from my variable. So I will add 5 to both sides. Again, do the opposite. Okay, I'm going to draw my line. And on the left side, I'm left with 5x. And on the right side, 7 plus 5 is 12. And then my final step, I'm multiplying 5 times x. So to get the 5 away, I would need to divide. And on the left side now, 5 divided by 5 is just 1x. And on the right side, I am left with 12 divided by 5. I can't reduce it, but again, if I wanted to change it to an improper fraction, I could, which would leave me 2 and 2/5. 5 goes into 12 2 times with a remainder of 2/5. Okay, there's an example of 4 multi-step problems. We're just going to try a couple more. Okay, these are a little bit different, but still the same idea. We still have the distributive property. The 1/3 is going to multiply by the 6x, and the 1/3 is going to multiply by the -9. Okay, so if we think about what the 6x is, the 6x is like being over 1. The 9 is also like being over 1. So you have 6x times 1, which is just 6x, 3 times 1, which is just 3, minus 1 times 9, which is 9, 3 times 1, which is 3, and that equals 5. So now what we want to do is reduce or simplify because this looks really complicated. 3 goes into 6 2 times, so we can write 2x. And 3 goes into 9 3 times, so we can just write 3. Okay, we have a couple more steps, so we'll do those up here. What we need to do now is we need to move the constants to one side. So what we're going to do is we're going to add 3 to both sides. And we'll write what we have left. So we have 2x on the left side. -3 plus 3 has gone away. And on the right side, we have 5 plus 3, which is 8. And right now, you guys are probably thinking, oh, I know what to do. Divide both sides by 2. So 2 divided by 2 is just 1x, or x, and 8 divided by 2 is 4. So if you want, go ahead and try this next example on your own. You might want to pause this video and then come back and watch and compare and see how you did. Okay, so if you tried it, let's see how you did. So remember, this is like being over 1 and this is like being over 1. 3 times 5x is just 15x. 3 times 1 is 3. 3 times -10 is -30. And 5 times 1 is 5. And that equals -1. Again, let's reduce because it looks very complicated with all those fractions. So 15 divided by 3 is 5. 30 divided by 5 is 6, and that equals -1. All right, we're getting there. Now we're going to add 6 to both sides and write what we have left. We have 5x equals -1 plus 6 is 5. And probably we don't even need to write it out, but we would divide both sides by 5. Can't really fit in there, it's very small. And our final answer would end up being x equals 1. Very good. Last example, and then you're on your own. Here's an example of a word problem, and it's good to think about word problems and how they relate to math and how you can turn these into expressions or equations. So think about what this says. 3 consecutive numbers add up to 66. What are the 3 numbers? Well, the first thing is we need a variable. So we'll say that x will represent the first number. And this is up to us. We could call it x, we could call it n, we could call it y. We use x a lot, so I'm going to use x. Well, if x is the first number, then what's the second number? The key is this word consecutive, which means in order. So if, for example, the first number was 5, the second number would have to be 6, and the next number would have to be 7. So if we say that x is the first number, then we would just take x plus 1, and that would have to be the second number. And again, we don't know where we're starting. We could be starting at 6 and go 6, 7, 8, Or we could be starting at 1 and going 1, 2, 3. So that's why we use the x, because we don't know where we're starting. Okay, and so now to get to the third number, what do you think? Well, we now would add 2, and that would get us to the third consecutive number. One thing that we're leaving out right now is the 66. Okay, we don't have that in there. Well, 3 consecutive numbers add up to 66. So we know that our total is going to be 66. So if we take x and we add that to x plus 1, and then we add that to x plus 2, because those are our 3 numbers, we should get 66. Now there is no multiplication to do, it's just addition and subtraction, even though we see parentheses. So what we can do is drop the parentheses, and then we can just add like terms. So I'll write it without the parentheses. And that's a plus right there. Okay, so we have x plus x. Actually, let's fix this plus. Otherwise, it's hard to tell what that is. Plus x plus 2. Okay, so we have x plus x plus x. That's 3 x's. So we have 66 equals 3 x's, and then we have 1 plus 2, so that's plus 3. Okay, we're just going to solve this like we have been all the other problems, and we're going to subtract 3 from both sides because we want to leave the x by itself. So we get 63 is equal to 3x. Final step, divide both sides by 3. And then we can figure out what our first term is. So in this case, x is going to be equal to, and I'm switching these around, but it doesn't matter as long as we keep 3x over 3 together and 63 over 3 together, that's fine. So I am just moving this x over here and this 63 over 3 over here. So x is equal to 21. So our 3 consecutive numbers are 21, 22, and 23. So we can write that here. They are 21, 22, and 23. And that concludes our lesson on solving multi-step equations. So give it a try, and if you need to watch this video again, watch the video and then try this on your own.